Okay, we started with 31. Somebody read the problem to me, please. Y equals 2 secant of x, and that's it? Okay, so where does that derive from? 2 cosine of x, right? You all right over there? You chilling? One, two, three. 1, 2, 3. 1, 2, 3. 1, 2, 3. All right, so 1, 2, -1, -2. So the cosine function, 2 cosine of x starts at 2, goes through pi over 2, goes to -2, goes here, goes to 2, and then I'm going to bring it back down to here again. So then where do I draw my asymptotes at? Pi over 2, 3 pi over 2, 5 pi over 2. And I draw next, what do I draw? Little parabolish things. Okay, looks like that. Yep. We're good? Okay. Next one, 41. Lots of 2's involved. So it's 2 secant of 2x plus 2. So I'm going to draw the whoa. Come on, computer. Don't go crazy. Pi over 2. Pi. 3 pi over 2. 2 pi. 1, 2, 3, 4, -1, -2. What I'm going to draw first is y equals 2 cosine of 2x. Okay. 2 cosine of x would be here, 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 right? So what's 2 cosine of 2x? That means it's twice as skinny. That's the word I was looking for, skinny. So if it's twice as skinny, it looks like this. Okay, like that. Okay, then we add 2 to that. So if we're adding 2 to that, y equals 2 cosine of 2x plus 2. Every point is 2 points up. Now, the big question everybody asks is, what happens to our asymptotes then if every point is 2 points up? Well, the shift of a curve, it just shifts it up. It shouldn't change where asymptotes are if you just shift up or down, okay? So if your asymptote was originally right here, when before the up and down shift, it should still be there. So we are there, and we're there, and we're there. So you have a parabola going like this, and a parabola down here going like this. Are we good with that? Okay, we're right here, and we're right here. Come, Kelsey. Got it all? Perfect? Good. Glad you do. Okay, next one, 43. Negative 2 cosecant of x. So I'm going to graph, negative 2 sine of x on this one. All right, so sine of x starts at 0, goes 1, -1, or 1, 0, -1, 1. Well, if you go negative 2 to that, you multiply each of the y values by negative 2, it winds up looking like this. True story? True story. Okay, where do our asymptotes go? Right here, right? Right here. And right here. So then, a parabolish looking thing here. And right here. We good? 43. Last one, 45. Last problem. What is it? Cosecant of x plus pi over 2. Boom, boom. So we have to do negative sine of x plus pi over 2. All right. So the sine of x normally goes here, 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 and here. So if it's negative sine of x, it goes here, 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 here. And if you go plus pi over 2, which way does it move it? To the left, pi over 2. So 6 squares to the left. 1, 2, 3, 4, 5, 6. So we're here, 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 here. Okay? And then draw on your asymptotes. Are we on the floor right now or what? Yeah, they don't show team scores, man. Okay, so that's what we look like, right? Yep, there we go. Okay, last section. Tangents. All right. Unit circles, get them out. What? Yep. They're just not good enough. So when you're playing basketball tonight, you go up to their center and say, "Your gymnasts suck." All right. What's the tangent of 0? Are you sure? Tangent is sine over cosine, which is y over x. What's y? 0. What's x? 1. 0 over 1 is 0. Okay? Pi over 4. What's tangent pi over 4? 1. Pi over 2. What's tangent pi over 2? Undefined, because it's 1 over 0. 3 pi over 4. What's tangent 3 pi over 4? -1. Thank you. What's tangent at pi? 0. What's tangent at 5 pi over 4? How about 1? What's the tangent at 3 pi over 2? Undefined. What's the tangent at 7 pi over 4? -1. What's the tangent at 2 pi? 0. Okay. So, looking at tangents. Okay. 0 is 0. Oh, I should put in some y-axis values here. We got 1, 2, a 3, -1, -2, -3. So we got 0, 0. Pi over 4, 1. Pi over 2, undefined. Undefined. If it's undefined, I should make an asymptote. 5 pi over 4, -1. Or 3 pi over 4, -1. Pi is 0. 5 pi over 4, 1. 3 pi over 2, asymptote. -1, 0. So what's happening here? Well, I'll do it in the middle. If these three connect, and we're going towards an asymptote, looks like that. Looks like that. It's always increasing. Tangent is always, no matter what, as a positive slope. Okay? We good with that? So then back over here, we'd go like this, and then over to an asymptote, and then down. Okay? Tangent. Everybody fine with tangent? Okay. Go tangent. Cotangent of 0. Undefined. Cotangent pi over 4. Pi over 2. 0. 3 pi over 4. Pi. Undefined. 5 pi over 4. 1. 3 pi over 2. 0. 7 pi over 4. 2 pi. Undefined. All right. So where's our asymptotes at? 0. pi, and 2 pi. So at pi over 4, we're at 1. At pi over 2, we're at 0. At 3 pi over 4, we're at negative 1. 1, 0, negative 1. Ooh, right there. So what does it look like? Well, we're going down this time. Okay, cotangent. Are you good with that? Okay. So then what will your homework problems look like? Well, they'll just be moderate little offshoots of that. There won't be too bad. All right, so a homework problem might look like this. What is the tangent of pi over 4x, or x plus pi over 4 plus 1? How about that? What does that do to the tangent curve? Moves it up 1, and what else does it do? Left pi over 4. Now, the normal tangent curve has asymptotes at pi over 2 and 3 pi over 2, correct? So what you're going to do right at the start, you have to know where your normal tangent curve is to graph these. So what I'll do right at the start, okay, so the normal tangent curve is at pi over 2 with an asymptote. So we're going to back our asymptotes up by pi over 4, okay? So we'll go with an asymptote right here. Back our asymptote up. Back it up, Chuck. Right there. And then we'll go right there. Okay? Then, halfway in between my asymptotes, I would normally cross the x-axis, right? But what do? I go up by 1. And then halfway in between that point and the asymptote, I normally go up 1. So I'm there. And I'm there. Closer to this way. Because look at the tangent. All we're doing is shifting it to the left, pi over 4, which is 3 squares to the left, and up by 1. So if you go left and up by 1, it would look like that. And then copy it over again. I want at least 2 tangent curves in each one of them graphed. Okay, when you get your homework. Okay? All right. So if I were to give you 2 problems now, you could muddle your way through the 2 problems, right? Okay? So on page 144, we're doing numbers 37 and 43. One tangent problem, one cotangent problem. Yes, that's not a lot, but it is what it is. Is Shanty having problems reading?
I got these 2 assignments from Tuesday. I don't know if you checked them.
Yeah, I did.
Yeah, so there you go.
All right.
And
Yep. I didn't walk around and check today, so don't worry about it.
okay, I'll get those done. I don't think you posted it on Classroom or anything, so I couldn't see it.
Didn't I post it? Oh, I probably didn't.
Yeah,
So
so that's all right. I wrote them down now. So.